So I'm Aodhan Fitzgerald, so I manage this vessel here and another couple of assets for the Marine Institute. And it's a real pleasure to be back in Bridgetown once again and meeting with colleagues from CZMU and farther afield. So I'm just going to talk about the preliminary findings of our recently completed Barbados Ocean Floor Survey. So just to give a little bit of background about the Marine Institute, but just first of all to point out what we call the real map of Ireland. So you can see the island of Ireland there on the just beside our bigger neighbour, the UK. So we've about 7 times our land area is in sea basically. So you can see there we have our EEZ, or Exclusive Economic Zone, is the red line, and then we have an extension of that, which is our extended continental shelf. You can see our sea area is not dissimilar in some ways to Barbados in terms of the depth. We're down to about 4,500 meters there, but we have a massive, relatively shallow shelf area, which is very rich in fish stocks and a lot of other resources as well. So the Marine Institute is situated right here in Galway Bay. This is our headquarters in Oranmore in Galway. We also have offices in Dublin, on the south coast, and on the north coast as well, so where we work with the local fishing community. So we're the state agency responsible for marine research, technology development and innovation in Ireland. We provide scientific and technical advice to government to help inform policy and to support the sustainable development of our resources. So we were set up under the Marine Institute Act in 1981, and our mission is to undertake, coordinate, promote and to assist in marine research and development and provide services related to that will promote economic development and protect the marine environment. So what do we do in research vessel operations? So we manage the Marine Institute research vessel fleet. Here's quite a rare shot with both of our modern vessels tied up in Cork. So we have the Celtic Explorer and the Tom Crean, which is the newest vessel. And we also operate a deep water remotely operated vehicle as well, the Holland 1. So we use a subcontractor to man and operate our vessels. That's provided by P&O Maritime Services, which is formerly an offshoot of the famous P&O line. But we in RVOps, we plan and schedule our vessels' activities, liaise with science leaders, manage things like the diplomatic clearance process, and we promote the vessels and their capabilities. So just a little bit more about the vessels. That's the picture on the top is not in Barbadian waters. It's up off the west of Ireland, and that's a pretty normal day for the vessel. So it arrived in 2002. It was really Ireland's first modern, large ocean-going research vessel. 65 meters long, 15 meters wide. It can carry up to 35 people, normally up to 20 scientists, and it normally does about 10 knots. It's designed to be acoustically silent as well, mostly for fisheries research, so that the vessel's engines are mounted on resilient mounts to stop the noise of the engines going into the water. So it means basically the fish don't get scared by the noise of the ship, but it also means that the ship creates a lot less noise in the water column. So anything you use acoustic equipment to image the seabed, it actually operates much better because it's to do with the signal to noise ratio from the ship. It's basically the return signal is not being masked by the noise of the vessel. It's got a huge array of scientific instrumentation, and it can stay at sea for up to 35 days. So this was the work we did in summer 2024, which is a bit of a contrast to summer 2025. So we were up there in a fjord in Greenland. So we usually do about 300 days of science activities a year. And most of the work we do is our own fisheries work. We do about 82 days of bottom trawling, 84 days of acoustic fishery surveys. We do oceanographic surveys and buoy deployments. And then we do about 100 days a year of funded and charter activity for Irish and international the academic community, including ROV surveys. So that's us. We spent a month in that fjord in Greenland. We had an ROV that went under the ice, under the 400-meter high glacier, the solid ice, to investigate the impact of climate change on the ice. And that was working for the University of Texas, of all places. And that's us actually on a previous visit to the Caribbean in 2006 when we did the Lesser Antilles Pelagic Ecosystem Survey. So that's a long time ago now. So the ship is very well set up for mapping the seabed. If you see here on the bottom right, basically Kongsberg, they're a Norwegian manufacturer of echo sounders. So the ship at one point had 3 of these on at the same time. We have the second one from the right there, which can map down to 7,000 or 8,000 meters, which is our primary multibeam. And then we have a shallow water system as well. And you can see where they are on the bottom of the ship. And the other one is a sub-bottom profiler there. So the ship is very well set up and a lot of people here have been on board and seen it, how it's a bit like a NASA control with all the screens in front of you. So we basically have 2 multibeams at the moment. One is an EM302, which is our deep water multibeam, can work down to 5,000 meters and beyond. We have a shallow water multibeam, which can go in as shallow as the ship can go, basically, and out to 500 meters. And then we also have a sediment profiler for looking down into the sediments. Then our smaller vessel has 2 multibeams, 3 actually, sorry. It has 1 medium depth multibeam and 2 shallow water multibeams. So that's our vessel called the Tom Crean, which is named after a famous Irish explorer who did 3 expeditions to the Antarctic, and he ended up being stuck on Elephant Island with the famous Shackleton, and did a very famous voyage. So we thought it was an appropriate name for our new ship. So it's also a diesel electric vessel, silent as well, but it's slightly smaller. And some of the guys here have had the chance to experience the vessel. So it does it stays slightly closer to shore. So it does a lot of work in Irish waters and French waters. We do some acoustic surveys on the vessel. We do a lot of underwater TV surveys for our prawn stocks. And we also do work for the French government and survey their prawn stock in the Bay of Biscay. You can see the little track there. So we do about 80 days a year then of seabed mapping under the program called Infomar, which I'll tell you about in a minute. And we do about 50 days of academic training for the 3rd level universities. Basically, our weather is pretty poor normally in November and December, so we actually use the ship inshore in one of our bigger harbours to bring out 3rd level students, which is really successful. And we also do things like egg and larval surveys. We do a lot of environmental surveying. And recently we did seismic surveying for the ocean renewable sector. As you can see in the bottom right there, we're towing a thing called an ultra-high resolution seismic system, which is looking at future wind farms off our south coast. And then we have our ROV Holland, which can go down to 3,000 meters, and we use it a lot from the Celtic Explorer. You can see it there being deployed. We also deploy it on other vessels as well. So it's controlled from the deck of the ship, so nobody has to go down under the sea with this. It's got a 4-kilometer long cable, and it's controlled from the surface in a 20-foot container. So it has robotic arms. You can see there's like 2 7-function manipulators for taking samples. It has various types of sampling tools for picking up creatures, picking up sediment samples. It can slurp up fish into little boxes. And we do a lot of photogrammetry there, so you can think that's an image of a wreck there at the bottom that's being pieced together from thousands and thousands of photographs. So there's more and more in that work being done. So we also support the National Data Buoy network. So we deploy and recover these weather buoys, which are off our coast. We also have various wave riders, Argo floats as well. We do a lot of oceanographic and climate monitoring surveys. So this is a CTD, which measures conductivity, temperature, and depth, and this can operate down to 5,500 meters. And you can see the sample bottles there, which can take up to 10 liters of water when you see something of interest on the readout. You can take a sample of that water and recover to the surface. You can also do a lot of grabs down to 5,000 meters. And this is the training I mentioned. It's through a partnership we have with one of the universities in Ireland, and we've put together a thing called the SMART, the Strategic Marine Alliance for Research and Training. So this is a really successful program that's been going for about 14 or 15 years. and up to 200 students a year from undergraduate and master's courses. And they cover geophysical, benthic and fisheries surveys, and we're seeing a lot of CVs coming through and people starting to work with the Institute that got their first taste for marine science on board our previous vessel, the Voyager, and now on the Tom Crean. So there's just an example of the equipment we use for our underwater TV surveys for prawns. It's a very non-invasive way of measuring the prawn stocks. Instead of trawling, we actually tow this camera on the seabed for 10-minute tows, and you can see the two little dots there. They're 75 centimeters apart, and we get a little video 10 minutes long, and our scientists count the number of burrows that they see in the 10-minute slot of the seabed, and then that's expanded out over the 280 tows that we'll do in the course of our survey, and it's got a very accurate way of seeing the health of the prawn stock. Unfortunately, it's too accurate because we've had a reduction, just heard of, up to 20% in our quota for next year, so the fishing community won't be happy with us, but anyway. So again, we do a lot of work, fishery surveys for commercially important stocks, and all this goes into the international, the ICES reports, and it's involved in the European Union negotiations for the various stocks as well. So then, just to I suppose the subject of tonight's discussion, we do a lot of work doing seabed mapping and geophysical surveys. You can see this is slightly out of date. The blue bits are the bits we haven't done, and of our map, which I'm going to talk about a little bit more in a second. So we're working our way through these blocks here off our south and west coast. I think this year we've covered 8,500 square kilometres, and we've about a year and a half left before we map our entire EEZ, which is probably one of very few countries with a large EEZ who's managed to achieve this. So as I mentioned, we can go down to 3,000 metres with the ROV Holland. So then I'll just talk a little bit more about the Irish seabed mapping and the Infomar programme, which really gives us the skills to and the experience to be able to undertake work like we've completed here. So it's actually funded by our Department of Energy. This programme has been running since 2006. We're in partnership with our Geological Survey of Ireland. The work is in our programme for government and our climate action plan. And we're focusing on the acquisition of data exchange and integration and value-added exploitation of that data. And we support cross-sectoral sustainable development, spatial resource and risk management. So the plan is to grow the data that we have available, the amount of scientific advice, and improve the economic impact. And the technology we use innovative equipment, multiple platforms, and we do a lot of work around research and innovation, project leverage. And the products that we have then, which is probably the most important thing, are at the end here. These are all free and open for exploration, development, and research. So just in terms of the milestones as we went along our journey for mapping our seabed. So in 1997, there was the first survey where we outsourced a survey. This is by our Petroleum Affairs Division, and they began the first steps to us making our claims through the UN for our extended continental shelf claim. And then we had the Irish National Seabed Survey followed, where we were doing a detailed survey of our deeper waters. So this was initially done with contracted vessels, and then it moved to self-survey, where our own vessels, including the Celtic Explorer, were brought in to begin to map everything from the 200-metre out into deeper waters. And then we began a sort of a multi-sectoral inshore programme in 2006, which was phase 1. So where we looked at various bays and coastal areas around Ireland. Then there was a lot of work to get funding and political support for the sort of progression of the project as we went forward. We began to get small and medium enterprises involved in terms of research and various projects between 2008 and 2012 and continue to this present day. We began to do a lot more work with colleagues in Canada and the US then, and we began an Atlantic mapping program between 2015 and 2017. And this leveraged sort of transits that we were doing back and forth across the Atlantic. And then we began the second phase of Infomar that is running currently from 2016 to 2026. We began to do more work then around the EU Habitats Directive, including 3 years of extensive seabed mapping using ROVs. It was under the Sea Rover program. You can see some of the outputs there where you can actually click the map here at any of the little red dots on the screen, and you get brought to a video image of these areas of interest below it. In 2019, we began our MSc, our seabed mapping module with University College Dublin, and with training on board the ship, and some people from CZMU have benefited from that. And then more recently, we're focused on the quality management framework for our data, streamlined workflows, and moving everything up into the cloud. And what's next for this fairly large program? There's a review and a foresight assessment of the project, and we're looking at the next phase now, where we go beyond, let's say, bathymetric mapping into the next phase, which is establishing marine protected areas, supporting the offshore renewable energy sector, and doing more work around fisheries. So the fleet that we use for this program is the Tom Crean at the moment, and we use these smaller vessels here which belong to our geological survey. So they do the little, you can see up the very north of the country, there's a very white little sector we call the white ribbon. That's what remains to do with the inshore vessels, and they've been working on that for 16 years now at this point. It's a lot slower as you get shallower, and we focus on the deeper stuff in the white areas there. Ironically, these are probably one of the more important areas for our fisheries resources, because we sort of began in the deep and worked our way in, but I think we're about 1.5 years away from completion now of the entire map. So what happens to the data that we generate, or what is the type of data? So we generate high resolution bathymetry, seabed classification maps. We get some backscatter products, which tell you a bit more about the seabed as well. We get sub-bottom profiling data, which tells us a little bit about the sediments and the sort of a bit more detail of what's on the seabed itself. And then we have the ROV imagery as well. And these are the top 5 types of data that are downloaded by the general public. And just an example of an application here in fisheries management. This is around looking at restoration of habitat for spiny lobster, which was one of our higher value stocks. And we identified the reef substrate that these spiny lobster live in, basically. And we've created bathymetric derived variables just to profile the fine scale structure that is, we'd say, high for higher levels of spiny lobster. So this helps to inform the fishery in this area. So again, a lot of our data will be used in terms of mapping fishing grounds, nephrops, as I mentioned, herring spawning grounds. We use this data for various types of modeling, oceanographic ecosystem modeling, flood risk modeling. We support a lot of SMEs, including a company called Ocean, who have become sort of global leaders in using small unmanned surface vessels for seabed mapping. We've done projects around hyperspectral data to inform seaweed resource assessment and the habitat suitability modeling, as I mentioned. So these are the top 5 sectors where our data is used. So this is probably a model for the data that's going to be acquired over the course of this program. So research and education, marine spatial planning, offshore renewable energy, geoscience, and fisheries and agriculture are the top 5 sectors that draw down on the data that we use. And this just gives an example of where nationally the data is asked for mostly. And it's around the centres of the main third level marine related colleges in Cork and Galway, actually. And we have a lot of national parties and bodies that utilise the data as well, from fisheries to geology, sustainable energy, and other research agencies. And the data is used internationally as well, largely for research. Our biggest users of our data are the UK, actually, followed by the USA. So it just shows that it sort of has a global reach, and it's used for research all over the world, actually. So then, I suppose, just wanted to draw a comparison between the two countries. This is the actual size of both our nations right beside each other. So I suppose we're small islands, but we're actually big ocean states. So Barbados is probably an even more extreme example of this, because your EEZ is 430 times bigger than your island, with an EEZ of 185,000 kilometres, whereas Ireland is 7 times larger than the landmass. But it's meant we're actually the second largest European Union EEZ. Portugal is the only one that's bigger than us in Europe. Obviously, France has lots of overseas territories, but it's Ireland and Portugal are the two largest EEZs in Ireland. But we're amongst the smaller countries in Europe. So how did we end up here? So we got an introduction to the CZMU through our colleagues in our Shared Ocean Programme, which is an Irish Department of Foreign Affairs Marine Institute collaboration, which works with small island developing states. So we got an introduction to the CZMU, and we had a delegation arrived in April, May 2024. And we went on to sign a memorandum of understanding in February 2025. And we had a lot of interaction with the ambassador to Ireland from Barbados as well. And it resulted anyway in this MOU being signed on the 14th of February 2025. So it was a real pleasure to start to meet people from the CZMU and to start to get a collaboration going. So one of the first actions we had after we began to work together was to bring some personnel from the CZMU to take part in our Infomar training program, our MSc program. So we had Dwight and Shawnee, who are here, came along to Cork, to the terrible cold of Cork, and they had 2 very good days on board, despite some small bit of bad weather. And then we had 2 people just this week on who took part in the 2025 edition of this training. So I think it's been a great success, and we're delighted with the opportunity to sort of reach out and extend the reach of this program. So then we had a great contract signing then on St. Patrick's Day this year. There was lots of dancing on the streets that day when we signed that contract with the CZMU. So that's the background, and that's just where we're coming from in terms of our infrastructure, the programs we're working on, and I suppose the experience that we have. So we began to look at the survey planning in earnest for this project. So our hydrographers had a sort of a deep dive into the actual EEZ of Barbados, and to try and put an assessment of how long we think it will take to finish the work. So we divided the EEZ into different depth bins from deeper than 5,000 meters down as far as 100 meters, and we divided out the amount of square kilometers in each depth range, and then we estimated the required mapping requirement for each of those areas, roughly. So it's about, when we looked at it, it's about 99 days if you were just not doing anything else except mapping. Obviously that doesn't take into account weather, having to come into port, transit out to the far end of the EEZ, mobilization, etc., etc. So we used a tool on the bottom left here just to estimate how long it would take to survey the area. So this is what our multi-beam, how it can perform. So what swath of seabed it can map at different depths. So you can see as it gets deeper initially, we can get a wider, because the beams come out from the ship at an angle like that. So the deeper it is, the bigger area you're insonifying. But there's a limit then, there's a technical limit, and the amount of seabed you can survey reduces again with depth. So we basically plugged that into the system, and we came up with this various approximate mapping times for all the different areas. And then with the CZMU, they identified these 2 initial areas of sort of, what's the word, I suppose, priority number 1 for mapping based on what they knew about the area. So then we just set about then to actually do what's called a line plan, to basically, what way will we use the ship, what way will we steam to go and acquire this data. So we went, if you look at it there northwest-southeast lines, and that's so that the ship won't be changing depth constantly, so that the water depth under the ship is more uniform, and each time you step out it gets deeper, as opposed to surveying in with the water changing depth and the suboptimal. As you can see the way here, you try and map along the contours like that. But the added bonus of mapping in this direction was that the swell, which comes from the northeast, was on the beam of the ship. So if the swell is on the bow, you often get problems with aeration, and your vessel has to stop mapping basically. So it actually made for a very efficient survey. And then we worked it out that we were due about 7 knots, which is the optimal speed to survey at. And we have about, for this area, we'd about 10,000 roughly kilometers to sail to map the area, and we estimated it would take us about 33 days to map the first 2 areas. So then we had to get here as well. It's obviously not too close. It's 3,400 miles from Galway, our home base, to Bridgetown. So we left on time as planned. We used weather routing to get us here in the most efficient manner. You'd normally go a lot farther towards Canada when you're coming down, but with the prevailing winds, we use weather routing to minimize our fuel consumption on the way down. And we actually started work on the way into Bridgetown. We began at the edge of the EEZ and ran what would eventually become a cross line that goes at 90 degrees to the main lines. And we continued that all the way down into Bridgetown. And then we arrived on the 14th of August. So our crew joined that evening, or they joined the following morning actually on the 15th of August, and we left that afternoon to begin the work. So we managed to do almost 5,800 line kilometers of survey over 17 days. And this has to be a record. We were operational for 97.3% of the time. In Irish waters, with the weather we have, often we'll be down to 60%, 50% operational. So we only had a little loss of time due to weather, I think 12 hours where we had to stop operations and let the swell die down. And then we had on the way out as well, we decided to do a technology transfer of some of our wave measuring buoys, which we have in Ireland, and we deployed 2 of those on the way out to begin the survey, one off Compset Bay and one off the north coast at Animal Flower Cave off the north coast. Yeah, so they were deployed on the way, and they've been measuring and providing data ever since. They will hopefully last for at least a year and provide really good wave climate data, which is very essential, I suppose, in the changing climate that we're all experiencing across the Atlantic Ocean. So we mapped basically from 17 meters water depth was the shallowest we mapped, and we mapped all the way out to about 3,000 meters there. So then we had a well-deserved break for the ship and the crew. We'd changed crew in the middle of the survey on the 1st of September. So it was great to get an opportunity to get some VIPs on board and some of the press and all that. So I think it was a nice occasion on board. That's just some shots of the vessel on its way down past. Can't think of the name. Spacetown, yeah. So then we started on the second leg. So we changed our vessel crew and our scientific crew, and we departed again on the evening of the 1st of September. So we never hang around too long. So we're back out again, and we finished off some survey work on the south coast and headed off to the outer half, out as far as the edge of the EEZ. So again, we surveyed well over 5,000 kilometers. We'd no weather downtime at all. At this leg, the vessel stayed operational the whole time. Our only distraction, and it was interesting to hear the talk last night, we didn't realize how far out these relatively small fishing vessels operate. So we got tasked to go to a mayday for a vessel that was sinking about 350 miles from Barbados, I think. And we arrived at the same time as an oil tanker, and actually the oil tanker offloaded the 2 crew who were on board. There's a bit of confusion though. They said that we were after coming from Madeira. We weren't fully sure, we actually don't know which direction they were going. So anyway, the two guys were rescued and they were brought to Trinidad, I think, on the oil tanker. So it all worked out well in the end. So that was our only little bit of downtime on that trip. So then we returned to port in Bridgetown. We did a bit more inshore survey, demobilized personnel, quick port call, some fuel, and we sailed again for Europe. So we arrived back into Cadiz in Spain about 13 or probably 14 days later. So what did we achieve? So in 34 days of operation, the vessel surveyed 44,640 square kilometers, which is actually almost the size of the Dominican Republic, and it's bigger than Denmark, bigger than the state of Denmark. So it's a huge sea area to map. And we, as I said, we did over 11,000 kilometers in terms of distance. We went from 17 meters out to 5,736 meters. So we mapped over 24% of the Barbados EEZ for the first time in high resolution. So it was, we would consider it a great success. And this is the resultant image then. You can see the colors tell you the depth. So it's from 5736 on the very outer part on the northeast side there, all the way down into 17 meters off Bridgetown. So this is a typical sort of output that we would produce under our Infomar program. So look forward, hopefully 3 or 4 more field seasons, we'll get this map finished in its entirety. So I have a short little video now showing the 3D fly-through. So you can see where we went in around the coastline of Barbados. It's a really spectacular sub-sea landscape. We've called the East Coast Canyon Complex here. These really deep and really extreme canyons. And you come in and there's coral reef at the head of the canyons. Again, you can see how steep it is. You're down into this, a lot of landslide debris and a lot of evidence of previous landslides here. There's quite a distinct seamount then as you move offshore. Yeah, there's another landslide called a block landslide, where you have an actual large block of rock has shifted. And these are part of the extensional blocks from the formation of the island and the region. And we've taken some license here. This is the Barbados Ridge Canyon Complex. These are temporary names now that we've put in here while the guys were at sea. So this is the almost fully processed data here. You can see volcanic cones here. There's quite a few of these as you move out towards the east. And you're moving down now towards these are the various thrust ridges and basins formed by the thrust ridges. This is where the Atlantic plate is subducting under the plate on the side of the Caribbean. So you can see various features from that, including compression ridges. And then you get right out into the abyssal plain. Then there's a subduction zone trench where the oceanic plate is going in underneath the other plate. And here's the abyssal plain, which is a relatively flat and featureless and really, really deep part. And one of the more interesting parts here, this is another landslide flow here, which is quite large. You can see the debris there. So there's some more features here, faulting and folding caused by the subduction. Some more volcanic cones. And at a few of these we saw sort of venting of methane hydrates and stuff like this. There's quite a few of these. Hope you're not all getting too dizzy. So there's a lot of landslides here. There's a headwall landslide here. There's this very large sediment plain then down at about 2,000 meters to the southeast of the island, with an erosional channel just on the upper slope. So I think we zoom right into the inshore section here. There's some more small landslides on the other side of the island, on the west side. Quite a lot of evidence of those. And then we've largely done the approaches into Bridgetown. So that's the main map showing the output from the survey. There we go. So there's only a very small amount left in the inshore area. So here's just some more stills from the 3D image. That's the sediment plain that I showed there earlier. This just shows again in a different color, shows the canyons and a bit more detail of the coral reef off the east coast. And here's some of the venting from some of those volcanic cones which are evident across the area. We acquire what's called water column data as well, so we acquire images of the seabed, but we also can record what's in the water column. You can see a lot of oceanographic features there. You can also use it to aid the output from your multi-beam as well. It's a huge amount of data, but you can see things like gas venting quite clearly in that. So then, just to show you the detail of what's been achieved, there's a global bathymetric chart of the globe called GEBCO, but I'm just going to show the difference between the GEBCO data for the waters we surveyed and the multi-beam data gathered during this survey. So this is from the GEBCO data. You can see the level of detail. A lot of this is based on satellite altimetry, which is not very accurate, and also maybe some historic surveys which were sparse and probably not quality controlled very well. So you can see there the change in the data there to the higher resolution, and the same here. Much more detail, far higher resolution all the way through. And then I suppose the biggest difference is that this map shows the depth difference between the GEBCO and the multi-beam that we've just acquired. Some of the differences are over 1 kilometer. So you can see here some areas are shallower by up to 700 meters, and other areas are deeper by up to 1,000 meters, which is fairly significant. I'm not sure how high Barbados is. Is it 50, 100 meters, 200 meters? So just the scale of the difference. So here's one. This circled area is about 15 kilometers by 15 kilometers. The GEBCO depth is given it as 1.2 kilometers deeper than the actual depth. So there's an entire structure that's not visible in the GEBCO data. So there's the GEBCO data, and there's the actual data. So it's in fact 1,200 meters difference. So this is evident all over the area. So you can just see the vastly different resolution that has been achieved. So just want to show a small bit around the speed of sound in water is essential when you're using acoustics in water. So we use expendable bathythermographs on the vessel, so the vessel doesn't have to stop. So these are effectively disposable, and then we'll log the sound velocity, the speed of sound in water, as you go along. But we did a comparison with so we stopped in this area to do a CTD using the ship's main equipment. And you can see the comparison between the expendable probes and the actual ship's main probe here. So it just shows that they're actually given very good data the whole way through. So this corrects for the speed of sound, which is essential for accurate depth measurement. Sorry. So this is just something that was mentioned last night. So we did a lot of planning before we came here. Obviously last year we were working in the Arctic. We had to do a lot of planning for that. But here we had to do a lot of planning for the conditions we'd experience here. And one thing we didn't know much about was the sargassum. And we could see in various satellite images the amount of sargassum. We weren't sure whether it would be an issue for the ship or not. This is just taken from our drone offshore, but it wasn't really an issue for the ship. I guess a smaller vessel it would be an issue. We were afraid it might end up underneath the ship and affect our sounders and stuff like that, but the ship is 6 meters deep, so it didn't really pose a huge problem, to be honest. But there were vast mats of Sargassum working their way down through the area the whole time. So just a little note on the Seabed 2030. It's an initiative by the Nippon Foundation and JEBCO to map 100% of the world's ocean floor by 2030 and make the data freely available for navigation, climate research and marine conservation. So at the moment 28% of the globe is properly surveyed to the level that we showed in the last few slides. But 100% of Mars is surveyed. Obviously Mars doesn't have a sea in the way, so it's a lot easier to survey it. But I didn't get a chance to work up the figures, but this survey has made a very strong contribution towards this goal, you know. You can see, I probably could zoom in a bit, but you can see the Irish EEZ there, and it's made a quite significant contribution. So, but given the scale of Barbados' EEZ, it will certainly make a fairly large contribution to this sort of goal. The survey wouldn't happen without the people. So we had a team from the Marine Institute on leg one. We'd some of our senior seagoing people, some of our senior managers on board, and a regular contractor that we use. And then we had 3 people from CZMU in the first leg. And then we had our ship's captain, Anthony Hobbin, and his crew for leg 1. And then we had a change of crew then for leg 2. So we'd a lady chief scientist for the second leg, and we'd 4 people from the CZMU on board. So, and I think in the second leg they made a lot of effort to do outreach. So they had outreach to schools, outreach to universities. They had a sort of a fairly structured sort of training program on board. And I think everybody got involved, and it was a real useful add-on to the survey as well. So that's it. Thank you very much.